Everybody go ahead and write down the title, the yellow title, proportional versus non-proportional linear relationships. Just write down that yellow title. So our state fair task from yesterday, do you remember what that graph looked like? Remember? It looked something like this. There was my line. Who remembers from last year how you tell if a graph is proportional or non-proportional? How do you tell? Okay, crud, I just looked your name. You're going to have to tell me your name again. Olivia.
Isn't it if all the dots line up in a straight line?
That's part of it, yeah, but that's true for both proportional and non-proportional. And we'll talk about that, so thank you for saying that one. There's something really specific that tells you whether it's proportional or not. Hallie, what do you think?
Is it if the line starts through 0?
Yeah, if the line goes through 0, 0, that's proportional. So just look at that line up there. So the one that's not going through 0, 0, that one is not proportional. And this is why when you guys did your task yesterday, some of you were kind of having a rough time trying to figure out the cost of a ticket because it didn't begin at 0, 0. Okay? So we're going to compare the differences between proportional and non-proportional. We're also going to learn what does linear mean. Who knows what that is already? Raise your hand if you know what linear is. So some of you. Okay. All right, on this next page here, I want you guys to write down the title. So this. And I want you to write down this first bullet. So write down the title and that first bullet. So this is a really good time, like if you have different colored pens, highlighters, colored pencils. It's a great time to use those. It just helps you study your notes better when everything's not always, just in the same color. You guys remember how yesterday we practiced underlining keywords? So like down here, the ones I would want to underline is linear, straight line, and constant rate of change. So to try to explain what that first, sentence here means, a relationship between two quantities, think of the fair activity we did yesterday. We were always comparing number of tickets to the what? Do you remember what the y-axis was? Number of tickets bought to the... No. Yeah, money spent, the total money spent. So see, those are two quantities, and we were showing that those have a relationship. But to be a linear relationship, you've got to follow this first thing here. So linear means that it is a, what kind of line? Straight line. But I don't want you just to memorize that. I want you to understand why is it a straight line. So think back again on our state fair activity yesterday. When I had the graph there, so if I had my graph, it looked like this. The line was straight, wasn't it? Why was the line straight? Why was it straight? What in the context made it straight? Walker? It's a constant rate of change. What was it though, like in the actual situation that was constant? The price of the ticket. All the prices of the tickets were what? 50. They were all 50 cents. So since the price of a ticket was always the same cost, okay, that made it so that the line was linear or straight. So when something has a constant rate of change, you're going to have a linear line. a straight line. Okay? Okay, guys, please make sure you're not on your phones and get your Chromebooks closed, okay? All right, a couple other things that we're not going to focus on a lot here right now is a linear equation has to have at least one variable in it. So when you're looking at a graph, you've got an x-axis and a what? And a y-axis, okay? What makes up an ordered pair? What makes up an ordered pair? Is it Sarah? Sarah.
Is it like,
What are the letters that are make up that they represent an ordered pair? Okay. What do you think, Callie? X and Y. That's how you plot a point on a graph, isn't it? X and Y. Yes? So when we write these equations, that's why a lot of times you see the X and the Y, because we're going to learn how to graph these equations. And when we do graphing, we're using points made up of X and Y. Okay? It says the dependent variable is determined by the independent variable. So in general, when you're looking at a graph, the x-axis is always your independent variable and the y-axis is your dependent variable. So to help that make sense more, yesterday on the fair task, the number of tickets was your x-axis. The total amount you spent was your y-axis. So how much money you spend depends on how many tickets you buy. Okay? That's your independent versus your dependent. Okay. So let's go ahead and we're going to practice identifying now. How do you see if something is proportional or non-proportional? Okay, so on this page, I want you guys to write down all of this top part. Whoops, sorry. Get this. I remember all these little things that we do here. And now it froze. I'm doing good, guys. There we go. Okay, so I want you to write down all that top part above that line. And then to draw your graphs, you don't need to draw all that detail on the graphs. Just draw one graph that looks like this and one graph that looks like this. That should be going through the origin. Okay, so I'll give you a little bit of time to write that down. Okay guys, what do you see is the difference between something being proportional versus non-proportional? Yeah. Yep, that is the only difference, isn't it? Are they both linear? Yes or no? What does linear mean? Straight line. So if it has a straight line, then it has a constant rate of change. Okay? So they're both linear. The only difference is one goes through the origin and one does not. So last year, and go ahead and just write this equation by years, okay? So last year you guys used this equation. Y equals kx. Do you remember that? Does that look familiar at all? So this was an equation only when something was proportional, and k represented your constant rate of change, but they call it the constant of proportionality. So for example, yesterday, the state fair task we did, was the graph on the state fair task proportional or non-proportional? What was it, everybody?
Non-proportional.
Non-proportional, because why?
Because it didn't start from the origin.
Yeah, it didn't. Why? Where did it start? Who remembers? Where did it start? You remember, Journey? There's the 8. Yeah. What was the 8 for? $8 to what? Enter. Yeah. So at 0, it was over here at 8 because it was $8 to go inside. Okay, so we're going to see if we can find the constant of proportionality on this first graph. And this is what threw people off yesterday because you were trying to do that graph as if it were proportional. Okay, so right here we're at 1 and 5 there. So that first point, when you always read these graphs, you want to read it by looking at the y-axis over the x-axis. Okay, so I'm going to read this as how many gallons of water have I used per minute. Okay, so let's start with the first point. At 1 minute, how many gallons of water have we used? Look at the graph, guys. At 1 minute, how many gallons have we used? Yeah, 5. Okay, I want you to write this down by it. So we did 5 gallons after 1 minute. Okay, what about after 2 minutes? How many gallons have we used? Just say it out, guys. What is that?
10.
Say it louder. 10 gallons after 2 minutes. And I could keep going and going on this and naming those points. Do those points have anything in common? What happens when you simplify both of them?
They always end up with 5.
What does 5 divided by 1 equal?
5.
Just say it. What is it? 5. What's 10 divided by 2? 5. Let's check out this point here. This one's at 35 gallons in 7 minutes. What's 35 divided by 7? So it's always coming out with the same rate. That's because this one is proportional. So how did you write the equation for it last year then? Y equals what? What's my constant of proportionality? That's the 5. That's the 5 gallons per minute. So I would write 5. What goes after 5? X. Yeah, just look at this original one. So this one was y equals 5x. So, okay, 5 gallons per minute. So if I've gone for 20 minutes, Jackson, how much should I have used after 20 minutes? 20 minutes and 5 gallons per minute. How much should I have used? You can use your calculator if you need to. What do you guys think? Do you want to help him? What do you think, Cole?
Would it be 4?
Not 4. Good try.
100?
So, yeah, 100. 5 gallons per minute, and we have 20 minutes. So look, you plug it in your equation. 5 times 20, which is what? 100, okay? All right, if we go and try to do that same thing on this graph, it's not going to work out because it doesn't begin where? Doesn't begin at the origin. So just to prove it, let's go through and name these. So look at this side here. Each of these marks goes up by 4. Okay? And some of those marks are right in the middle of them. So let's start with this one here. Oops. This one. Where is that point at? What's the inches in between? It's in between 12 and 16. So what is that? 14. So we're talking about a fir tree. The diameter is how wide it goes across through the center of the tree. So we're trying to figure out how many inches does that diameter grow per year. So after 10 years, how big is it?
14.
14 inches. Yeah. That's in 10 years. Okay, let's do the 20. 20 years. What is it? 18 inches. All right, are those going to simplify to be the same thing like this one did?
No.
Those ones all went to 5, didn't they? Go ahead and grab your well, let's just do it without the calculator. Let's leave it as a fraction. What does 14/10 simplify to? What goes into both 14 and 10?
5. Oh, no. 2.
2. So divide each of them by 2. So 7, what? Fifths. So 7 inches in 5 years. Okay, let's do the same thing with the other one. What does that simplify down to? 9/10. So 9 inches in 10 years. Now, if I want to compare those, I've either got to have a common denominator or change them to a decimal. So please pick up your calculator. What's 7 divided by 5? Okay, now what's 9 divided by 10? So are they the same? So that's not my constant of proportionality then. I know there has to be one because this line is a straight line. So I know it's constant. But I can't find it like that because it doesn't begin where?
0. In the origin.
The origin. Okay? So let's think about this in like real life. Okay? So we're going to say that, who do I want to pick on today? Josh. Josh? Yes? Josh. Okay. We're going to say Josh wants to buy a fir tree and go plant it outside his window. Okay? So Josh goes to the store. Guys, what do we know about that fir tree when he buys it from looking at that graph? When he buys it. He's had it for 0 years. He just bought it. What do we know about that tree already? What do we know? Jackson, what do you think?
It's not going to grow quick.
It doesn't grow quick, but we're saying he's buying it, so he doesn't have all this data. He only sees the first point at 0 years. What do we know about it then at 0 years? Josh?
10 inches.
It's 10 inches tall. How'd you do that?
Because the first one is at 10.
Yeah, the first one's at 10. Guys, does this go through the origin? Yes or no? Does it go through the origin? So look where it's at. When he went and bought the tree, it was already right in between 8 and 12. So the tree started at 10 inches tall. Generally, when you go and buy a tree, it's already grown some, huh? So did we take that into account the first time we tried to find the rate of change?
No.
No. Do you think that messes it up?
Yes.
That's like the state fair yesterday. Some of you are going through and saying, oh, the first ticket is $8.50. And then for, I don't know what it was. Oh. Like 10 tickets was, what?
$13.
$13, something like that. Remember? And it wasn't working out nicely. That's because, did you have an entrance fee? Yeah, you had a fee to get into the fair. Well, this tree started growing long before you got it. Didn't it? So it's been growing for a while. So we've got to take that into account. So let's look at how much would it have grown after 10 years that you've had it. So how tall is it at 10 years?
14 inches.
It's 14 inches tall, yes? How tall was it when you bought it?
10.
So how much has it grown in 10 years?
4 inches.
So it's changed 4 inches in 10 years. Okay, now let's look. What has it done after 20 years of you having it? How tall is it at 20 years? Everybody look at the graph. How tall is it? It's right here. Yeah, it's at 18. So remember, you bought it when it was how tall? 10. So how much has it grown? 8 inches
Oh, that's a lot. Oh,
in 20 years.
never mind.
Now that doesn't, okay, I'm sorry, it wasn't 10 inches tall. I keep saying tall, but it's not the height, it's the diameter. That tree gets, so we're not looking at how tall the tree is, guys. We're looking at the thickness of the trunk. So it's growing good. Yes?
I wasn't wrong.
Yeah. Okay. All right. Now let's see if these are the same. Because if it's my constant rate of change, it's always got to be the same. What does 4/10 simplify to?
2/5.
2/5. So 2 inches every 5 years. What does 8/20 simplify to?
Also 2/5. Wait. Yeah, also 2/5.
If I cut them in half, it's 4/10. I cut that in half, I get to what?
2/5.
2/5 again. So did I find my constant rate of change? Yeah, so this tree, its rate of change is it grows 2 inches every 5 years. Now, yes, you could divide that, but if I wanted to keep graphing it, it's way easier to leave it written as 2 inches every 5 years, because look at what the graph is counting by.
Fits.
It's counting by 5s, right?
Oh, yeah.
So you want to leave it like that. Okay, this is the new equation you're going to learn this year. Will you please write that down underneath the proportional side?
Oh.
Make sure it's underneath non-proportional, sorry. So proportional, we never saw anything after, the y equals 5x. It was just done there. Non-proportional,
Why?
we use this equation here.
M.
So M represents your rate of
Change.
change. It's also called the slope. What was our rate of change for our fir tree?
2 inches every 5 years.
Yeah, 2 inches every 5 years. We don't label it, we just write 2/5. What goes after our rate of change? Look at the formula. What goes after the rate of change? What goes after M? Say it loud. X. Am I done?
No.
What do you think the B is for? Where it
Begins.
began.
Oh, really?
How wide was it already?
10 inches. Wait, yeah.
Well, so we have to remember that every time. We have to add on 10 because it began with a diameter of 10 inches. Now, guys, this formula is pretty much the same as this one. It's just, where did you begin here?
The origin.
You began at 0. Do I need to write plus 0? I could, but would we want people to? Is that in simplest form? Does adding 0 do anything?
No.
So last year when you guys did these, you were always looking at, what's the constant rate of change? But that since they all began at 0, you never learned about the B. So the B tells us where it begins, and we call it the initial value. Initial means beginning. Okay? So if I have a couple equations and I want to tell is it proportional or
Non-proportional.
non-proportional, what would be the quickest way to spot it?
To look at the first one. Oh, no, to see if it goes through the origin.
You're trying to see, does it have a B, basically. If it doesn't show a B, then that means it was plus 0. Okay? All right, we're going to continue here tomorrow. What's your assignment tonight?
To turn in our
Turn in
paper.
the
Yeah,
Fair.
finish the state fair, correct it, then submit it.